Okay, so today we are talking about the chain rule. I'm calling this 3M, the chain rule. And right now you may think that the number of functions that you can take the derivative of are pretty significant. In reality, it is not. You are very limited in what you can take the derivative of. Now, you might be able to just sort of do some sort of process, but that would not be the correct process. Okay? So y'all tell me, what are the types of things, what are types of functions that you can take the derivative of? What type of function family? What function families?
Cubic functions and quadratic functions.
Okay, yep. So this is what you know. You know how to take care of cubic functions. So stuff like x cubed. You said quadratic, stuff like x squared. I'm not going to write all the words down, but yeah. As well as plus any term after that, right? So x to the squared. In fact, you can take care of any x to the n plus x. Out of practice here for a day. I'll tell you, you lose everything. Plus x to the m plus a x to the p. Da, 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 da. Okay, what type of function is that? Do y'all know? Anytime we have the x right here is the base, and then some number. Just trying to work on some terms here.
It's not a trinomial because it.
No, it's not a trinomial.
It's
It's a many-nomial, which is a polynomial.
Oh, a polynomial.
Right. So you know how to take the derivative of any polynomial. Check. You just use the power rule, okay? You take the exponent, pop it down, then power down. We're pretty good at that. Somebody else, tell me, what's another thing that you know, another function family that you know how to take the derivative of? Something that even more basic than polynomials.
Linear.
Okay, linear. Technically, linear functions like 2x plus 3, that is a polynomial. Scale it down even more, I would say constants. Okay, so you know how to take the derivative of a constant. What is the derivative of a constant, class? Zero, yeah, so we know that. Polynomials was with the power rule. There's another 6 functions that you know how to take the derivative of, but you didn't have to do that on the quiz yesterday. Namely the
difference in quotient, or no.
What she's saying, sine, cosine. So you know this, how to take the derivative of the 6 trig functions, okay? So it seems like we're doing pretty good. What about radicals? Can we do the derivative of a radical function? I think so. For instance, if we had f of x equals the square root of x, what would we do to take the derivative of that type of a function?
X to the 1 over 2.
We'd rewrite it as x to the 1/2. Okay, so that's, maybe we can take quite a few radical functions. Also, I would say stuff that looks like this, x times sine x. We can take the derivative of functions like that. Namely, any product of these. Okay? So you don't necessarily need to write all this stuff down. This is just sort of us being aware of what we know so we can more quickly identify what we don't know. So any product of those and any quotient of those. For instance, x divided by sine x. We can take the derivative of that using the quotient rule. We've seen some of that. We actually did a proof of the product rule. We did a proof of the quotient rule. Let me ask you about this though. What if I had f of x equals the sine of x squared? What type of a function is that? This is where our notes actually begin. This is now. First off, what type of a function is that?
It's a trig function.
Okay, the sine is a trig function. But somebody else might say it's a
Quadratic.
might say it's a quadratic function. So who's right?
Both.
Both? Someone is more right than the other.
The quadratic one?
No, sorry. Good guess, 50-50 chance. But what I would, if I were to argue this, I might say, well, this is more a sine function than it is a quadratic function, because the sine function is on the outside. It's the outermost function. It's sort of like the one in charge, right? Now it is taking the output of the x squared, whatever, when you get x, you square it, but then that number gets fed into the sine function. Would you all agree with that? Do you understand when I say outer and inner function? Outer function is sine, the inner function is x squared. So I would say that this is a sine function composed of a quadratic function. And so now we're going to ask, well, what's the derivative of that? And you're like, got this, Mr. Goddard. I know what the derivative of sine is. It is cosine. So I think that f prime is equal to cosine x squared. And I would come back and say, it's all a conversation here at this point. What's your proof of that? Like how do you justify that? And you say, I got this. You told us that, I'll even use the specific notation, that the derivative with respect to x of sine x is equal to cosine x. Therefore, the derivative of sine of x squared is cosine x squared. And that would be a pretty good response. But I'd come back and hammer you on this one and I'd say, yep, here's the problem. That is showing sine of x, which is just a linear argument, okay? What we have here
X squared.
is x squared, which I would argue is actually like a function, okay? It's x squared. So what you told me, that this is true, but that is not enough to get us from here to here, because it doesn't fit the pattern. This pattern says, this formula, you can have the sine of x, that's it. Just the sine of x is cosine x. You put an x squared in there, all bets are off. It doesn't work, okay?
That was not as dramatic as I thought it was.
Okay? So, this is what we're trying to solve. This is what we're going to try to figure out, okay? How to deal with a function within another function, okay? So, we're going to come back to this when we're finally finished, okay? So, just give yourself a little bit of space there. You all right, Hector?
Yeah.
All right. So here's going to be our proof of what's we're going to know as the chain rule. Okay. So there's a couple of recall things that we're going to need to remember. Okay. So remember this: f prime of x is equal to the limit as delta x approaches f of x plus delta x minus f of x all over delta x. Shouldn't be too hard for you to remember. That's the definition of the derivative.
Yeah.
But there also was an alternate form of the derivative at a point C. And that was this. F prime evaluated at a given point is equal to the limit as x approaches C of f of x minus f of c all over x minus c. That should look familiar because you had to have that one memorized as well.
And so there is H2. No, okay.
So here's what we're gonna do. We're gonna say that we have
Let's see.
some function h of x, okay, which is equal to a big function, an outer function f, composed of, you may remember composed of from pre-calculus and even algebra 2 a little bit, g of x. So big function of f of x and a little function inside that. In that example over there, this would be like sine of x squared. Okay? And I'm going to now apply this formula right here in terms of finding the derivative up here. So here we go. So I'll say h prime evaluated at c is equal to the limit as x approaches c of, I'm going to try to follow this pattern. So this was f of x, which is going to be f composed of g of x minus f of c, so it's going to be f of g of c all over x minus c. Go ahead and look at that for a second and see if that makes sense to you. Anybody have a question on what we did there? In case you want to make a little note of yourself, we're just applying this formula right there. Okay. So, unmotivated step here. For no apparent reason, I'm going to multiply this by g of x minus g of c over g of x minus g of c. So now I have h prime evaluated at c is equal to the limit as x approaches c of, and for the most part I'm going to keep this numerator as was, f as is, f composed of g of x minus f composed of g of c times, I'm going to keep this the same, g of x minus g of c. But I'm just going to rearrange this a little bit. I'm going to put this term right here over here, and I'll put that term over here. So I have g of x minus g of c, and I'll put x minus c over here. All of that. And then all of that. Times right here. So now we have h prime of c equals the limit as x approaches c, and this is going to be pretty short proof. We're almost done. I'm just going to say the limit of this product is equal to the limit of the first thing times the limit of the second thing. Hector, Stephanie, thank you. F g of x minus f g of c all over g of x minus g of c times the limit as x approaches c, g of x minus g of c over x minus c. Now we're going to do some careful examination here. And I'll start off with the easy one. What does this look like, class? This one over this bracket here. Limit as x approaches c of g of x minus g of c over x minus c.
Looks
F
like what
of
you
delta
started
C.
with, kind of.
No, like of this?
Kind of looks like
Mhm.
f of delta c.
Or like, yeah, like,
It looks like this.
Yeah.
The alternate form of the derivative evaluated at a point. I agree, okay? So now this was all dealing with f, right? So that was f prime evaluated at c. So what do you think this one would be?
No, g of prime c.
There we go. G prime evaluated at c. Great. You're off the hook for the hard one.
Oh, okay.
What does this look like?
That one looks like h of x. No, I'm playing.
It does look like a little bit of like h of x because it has f composed of g, right?
mm-hmm.
In fact, and I hear Rosa whisper, it looks like the same thing. Because, in fact, what I'm wanting you to kind of see is that this is limit as x approaches c, but instead of saying f of x, we have f of g of x. And then instead of saying f of c, we have f composed of g of c. And then instead of saying x, we have g of x, and then minus c, we have g of c. It's kind of like every place there was an x,
You put a g.
we put a g of x, right? Okay? Because every time there was a c, we put g of c, right? So, since this was f composed of c, then it seems like this would, or f prime, this would be f prime composed of,
g of x.
you're close,
G of c.
g of c. That is the derivative evaluated at a point. If we want to make this a little bit more generic, then I would just say h prime of x equals f prime of x, whoops, f prime composed of g of x times g prime of x. Let's see. So what we're looking at here, if f is the outer function and g is the inner function, then f prime composed of g of x, we would say this is the derivative of the outer function, so f prime, composed of the inner function, so derivative of the outer, composed of the inner function, times the derivative of the inner function. Let me say that again. F prime composed of g of x. So that's the outer function with the derivative of the outer function. And then inside, it's g of x. Inside, it's going to stay the same. So the derivative of the outer with the inside staying the same, times the derivative of the inside. I'll write that down for you. H prime of x equals the derivative of the outer.
So it's kind of like that first times the second derivative, something like that.
It is kind of. So it's a derivative of the outer with the inside intact times the derivative of the inside. So f of x equals sine of x squared. F prime is going to equal the derivative of the outer. What's the outer function is sine. So the outer is sine, the inner is x squared. So the derivative of the outer, so just kind of like you want to just say this sine of blah, okay? So the derivative of sine of blah is cosine of blah. Does that make sense? Sine of the derivative of sine of x is cosine of x. The derivative of sine of x squared is cosine x squared. Chain rule times the derivative of the inside. 2x. Done. And you can say, but why? Because that's our proof.
When I first saw it, I almost thought that the derivative of f of x equals sine of x squared would be cosine of 2x.
Right.
That's what I almost
Yes, that's another reasonable guess. But it's not. It's cosine x squared times 2x. And if we could do some graphical analysis and stuff like that, we could. But why bother? We did this for any function composed of any other function. As long, so that's pretty good. So this is completely generic. Eventually, I'm going to tell you how to take the derivative of like logarithms and like exponentials and like all kinds of other weird stuff.
Wow.
And this chain rule will apply to all of that. The chain rule is like the gates are now open. You can take any function that you've previously had, you can have that inside another function, and you can do the derivative of it. Okay. Let's do another one. What about if we had y equals the square root of 3x squared minus x plus 1? My first question is, what type of a function is that?
Radical.
A radical, but that is mostly right. On the outside it's a radical, but what is it on the inside?
Trinomial.
Yeah, it's a quadratic trinomial actually. Okay, so just like always, before we take the derivative, we need to rewrite this as 3x squared minus x plus 1 to the 1/2. So we're going to take the derivative of this. So just using some different notation here to get you comfortable with it. dy over dx. The outer function is, can you all see? I think we just said the outer function is the 1/2 power. The inner function is the square, blah, blah. So I'm going to make a fist or a hand or like a blah, like it's a hand turkey or something like that. I don't know. But I would say it's going to be blah. The derivative is blah to the 1/2, right? So just completely ignore the inside, okay? Let's take the derivative of hand to the 1/2. Well, that's going to be 1/2 hand to the negative 1/2. Make sense? So 3x squared minus x plus 1. The derivative of the outer function, you just pretty much treat this like this was one big x. Make sense? Like when you have x to the 1/2, the derivative would be 1/2 x negative 1/2. That makes sense, Hector? Okay. So now we have 1/2 blah 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 to the negative 1/2, but then we have to remember the chain rule. So times, put some parentheses. Say it again. 6x minus 1. Hooray! So now I can actually make homework that's literally just the other homework, just combined in 2 problems instead of 1. Alright, that's it. That's the chain rule.
Think that's the answer?
Yeah, that's the answer. It's literally you take the derivative of the outer, put the inside intact, and multiply by the derivative of the inside.
Nice.
Shall I give you a tricky one?
Yeah.
Y equals
Give us the hardest one on the worksheet.
tangent squared of x. I probably shouldn't have done this one. This one's too tricky, but it's okay. This one is tricky because of what the outer function is. Anybody know what the outer function is?
The outer function is tangent of x. No.
This is
Oh
like-
no, the outer
this
function
is
is x because it'd be like tangent squared in parentheses
It'd be
multiplied by x.
No. The way that what this actually means, I have to do a rewrite. That's what it means.
Oh yeah, you told us that.
Oh,
So yeah, tangent squared. Then speak up, 'cause I can't hear you. So 2 is going on the outside there. So the outer function is blah squared. The inner function is tangent x. So still using alternate notation here for sake of example. So y prime is
2 times tangent of x, and I'm not sure how.
you could put it to the first, or you could just put 2 tangent of x. I'm going to put it to the first right there because this is our sort of learning.
So it'd be the
process.
whole thing to the first, right? Not x to
You
the,
have to put
no, it
prime.
wouldn't be. It wouldn't be x to the first.
No,
Because-
because it's the whole thing, yeah. So,
So-
and there is an X to the first by coincidence because I don't have anything else there.
But if it were like something else, it wouldn't be that. It wouldn't be x to the.
Right, yeah, if it was like if this is like a 3, then it would be 3 and then there's a 2 up here. Okay, someone had derivative of the inside?
Squared X.
Secant squared x. So if I want to rewrite this, I'd say 2 tangent x secant squared x. Okay, we're doing good. Let's try. Let's say we've got g of x is equal to. What if I had something really weird? I don't know. The square root of cosine of 2x. What is the outer function there, class?
1/2. No, 2 the 1/2, like the square root.
Okay, yeah, the square root. What's the inner function? Maybe,
2x.
maybe.
Cosine 2x.
Yeah, then we've got 3 layers on this one. Y'all see the 3 layers?
The x
What is the
cosine
innermost function of
2x
2x?
and squared.
Because it's cosine 2x.
See?
So it's cosine
Yeah, that's
2x, get 1/2. We are going to have to apply the chain rule repeatedly
So
on
like,
this one.
do the chain rule and then do the chain rule on the answer.
Yep. So, derivative with respect to x of g of x is equal to, always gonna be the same pattern here. So the outer function, so 1/2, blah to the negative 1/2. So just the outer function and then keep that inner function intact. So cosine 2x times, now I have a new problem. I need to take the derivative of cosine, which you can't really read, that's really poor reading. Anyway, cosine 2x, so cosine 2x itself is an outer function and an inner function. The outer function being cosine, the inner function being 2x. So it's cosine of blah. What's the derivative of cosine?
Negative sign.
Negative sine. So negative sine of blah. So negative sine of 2x. Then times the derivative of its inside. Derivative of 2x is
2.
2. So you just carry that along. Alright? If I wanted to do a little bit of simplification, I'd say that 2 cancels out this 2. I've got a negative, and then I could pull this into the denominator, so I could say negative sine of 2x divided by, I push this in the denominator, that will turn into a square root cosine 2x. Okay? Lots of good stuff that we've been talking about here. Big picture here, big formula. Previously, we had the power rule, the derivative with respect to x of x to the n equals n times x to the n minus 1. With the chain rule, we'll say the derivative with respect to x of u. Hold on. We'll just say u to the n, where everybody knows that u means u of x. So I'm purposely putting a different letter here than the variable of integration because u is some sort of function. Okay? And the power rule with the chain rule combined here is going to be, okay, so u is some sort of function, so it's blah to the n. So it's going to be n times blah to the n minus 1 times the derivative of the inside, so the derivative of u, okay? I could put, the way that we normally write that is u prime. This is the new power rule. So imagine if u was like sine, okay, so it's the sine of x, or it could have been, you know, who knows what it is, but anyway. I'm getting some weird looks because I put u instead of parentheses. You gonna be okay with that? Alright. So that's the new version. This is the version that I'll expect you to have memorized. The derivative with respect to x of u to the n is n u to the n minus 1 times u prime. Okay? In the same way, before we had the derivative with respect to x of sine x was cosine x. Now we're going to have the derivative with respect to x of sine u is cosine u times u prime. Get that? You might need to write that down there, Ivan. So you see what I'm saying? I no longer have sine of just boring old x. It's always sine of some function of u. Okay. All right. Table practice time. F of x is sine cubed of 4t. Go ahead and find the derivative as a table. And I'll have another one ready for you when you're finished. Sine cubed of 4t. Ooh, good question. All right, I'll answer that. So you would say it's sine cubed and then 4t's in there. And while we're talking, what's the way we could rewrite this, class?
Sine of 4t in parentheses.
And then I'll put
Right.
I'll put the brackets so you don't get confused about the parentheses. Yep, that's how it is. When you finish that, you can start on this one. Answer them. Okay, and now I'll try the next one on the board. Let's put those brackets the same way as we have on this one.
You pop down the 3, left the inside intact, leave the inside intact, the sign needs to be signed right there. Then you power down, that's the first step, then we say times, now let's take the derivative of the inside.
Do I still put it?
And we already took the derivative of the outside, so now, I'm just looking at this stuff in here, what's the derivative of sine 4t? Times, let's do that inside, there you go.
That's good, keep going. Which one am I looking at here?
This one's finished.
Okay, keep going. Which one?
We could simplify that. A lot of y'all have this one already taken care of, so I'll just write this one down to f prime is, y'all pop down the 3, yep. So 3 times the sine, that 4t is intact, squared. Then, times the derivative of the inside, what's the derivative of sine 4t, class?
Cosine
Cosine
4t.
Cosine 4t. Times, chain rule,
6.
4.
4. The derivative of 4t is gonna be 4. And if you want to rewrite it here, you get 3 times 4 is 12, so you have 12 sine squared of 4t times cosine 4t. What's going on with this one, class? Go ahead, Emily.
The x squared is on the outside,
Mm-hmm.
and so then it's like one of the double ones that we've had, where the other side, and then you have to do it again for the 1 minus x squared.
Okay. What is the outermost function in this one?
The x squared.
You guys say you're both right. Time. It's neither the x squared nor the 1 minus x squared all to the 1/2 power. Not, this one is not totally on the outside of this one. They're actually beside each other. And they're being multiplied. So what this type of a problem is this is a multiply problem. This is a product problem. And I need to apply the product rule here. There's not a clear big fish with a little fish on the inside. There is a big fish right here, parentheses, 1 minus x squared, with all to the 1/2. But that is exactly side by side with this x squared. Does that make sense?
Mm-hmm.
So this problem is a horse of a different color. This is a product rule problem with the chain rule on the inside one of those parts. Combining their powers. Here we go. Alright, so that was g of x. So g prime, y'all remember the product rule? The first times derivative of the second plus the second times derivative of the first. So the first, x squared, times the derivative of the second. So the derivative of the second, now I'm going to have to apply today's lesson, the chain rule. So 1/2, 1 minus x squared to the negative 1/2 times the derivative of the inside. Derivative of 1 minus x squared is going to be what, class?
Negative x.
Negative 2x?
Yes.
Okay. Plus, so this is the first times the derivative of the second. That's that whole thing right there.
Plus
The first times the derivative of the second plus the second, so 1 minus x squared to the 1/2 times the derivative of the first, 2x. So the idea here is that this type of problem is not like those other ones where there's been a clear outer and a clear inner. This one has two of them side by side. With that being said, we could do some simplification here now if we wanted to. That 2 cancels out that 2, the x and the x become x cubed in the numerator, so we have negative x cubed over the square root of 1 minus x squared plus 2x times the square root of 1 minus x squared, if you want to do something like that. And then, anyway. Does anybody have any questions on this? Chloe, does that make sense that we've got this thing times that thing? Yeah, a little bit of calculus is sort of training your brain to look at functions and immediately kind of start sorting out what is going on. Is this a big picture? Is this a multiply or a divide or a composition? Along those lines, what do y'all see right here on this problem? What type of a function is?
It's like a quotient.
It is like a quotient. See, you're thinking like I said. And you would have to use, if you're taking the derivative, the
quotient rule.
The quotient rule. Low d high minus high d low over low squared would go. And in the process of all that, we don't have time for this in class, but you would have to use the chain rule
to take the
derivative of the denominator. What about this one?
Well, the outer thing is a square of quadratic.
Yeah, it's like, yeah, the outer thing is like blah squared, so it would be like a chain rule type thing. But then when you took the derivative of the inside,
You have to do.
you'd have to use the quotient rule. Oh, that's ugly. Hopefully Mr. Goddard doesn't give you any problems like that.
Yeah.
For homework. There's one more thing I want to highlight because this is on your homework. Just a trig thing, notation wise. In some cases, in one of your problems, it's gonna say sine of 2x squared. What that means is the sine of 2x squared. They don't like putting parentheses around the arguments there. I don't know why, but what's the outer function in this class? This one class.
The sine.
The sine.
It's
You
not
could-
the square.
It's not square, yeah. If I wanted to have sine squared or whatever, and then if I wanted to have the whole thing, yeah, put it right there.
Right.
So yeah. Okay. Some of these problems will take you just, a few seconds. Though I did give you lots of room. Was anybody absent yesterday? Okay. So I'll try to have those tests or those quizzes graded for you by the end of the day.
So
Goodbye.
for our corrections, are we allowed to ask you for
Yeah,
help?
absolutely. Yep. I'll give you the answer key.
I have some that there was one that I still, I was looking over and I still don't know why I got it wrong.
Today is Wednesday, so let's call this due Friday. Today we talked about the chain rule. Good job, class.